Day 5 of CCNA 203.01 training. Today we are going to discuss about networking models. But before that, I want to introduce you a device which is used majorly in networking and is represented by this, known as router. So in previous classes, we learned about the working of switch and hub. So since this is the day 5 of the training, I guess this is the right time to introduce you to the device known as a router. So a router is responsible for making communication possible between different networks. So as we discussed earlier, let's say there is a switch which is connecting two PCs, PC A with a PC B, and these devices are under network 192.168.1.0. Then here we have another switch which connects PC C with PC D. And these three devices are connected under network 192.168.2.0. As we all know, that a communication between these two networks won't be possible if we connect them together over a wire. But if we connect them through a router like this and configure some routing on this router, then after configuring the routing, A, B, C, and D will be able to communicate with each other. So that's something where a router is needed to make inter-network communication possible. So this is switch 1 and this is switch 2. So whenever A will try to communicate with C, the information will be first sent to the router, which is also known as gateway. And after that, this gateway will forward the packet to switch 2, from where C will be able to receive the same. Now, under this whole topology, there is something which is working inside, known as networking model. So today we are going to learn about this only. We will be discussing everything about networking models, and let's start. Okay. First of all, let's understand what a networking model is. And the best example I can give for a networking model is a networking model to a network is something which is a blueprint is to a house. So when we talk about networking model, we can consider it as a blueprint for a house which is under construction. And if we follow the blueprint, everything can be done as per the requirement. So it makes us easy to understand where the issue is, even if there is some problem in the, let's say there is a house which is being built according to the blueprint. And if the plumber, or let's say the electrician, if they work according to this blueprint, they will be confident that their part of work is done and is correct. So a blueprint really helps us to identify where exactly the issue is. So now when we talk about networking model, just like a blueprint, it has multiple layers. And when we follow the networking model, we can easily identify where exactly we are lacking, or what exactly, or which layer exactly is being used for the communication or for the particular action which is being held between devices. So we will be learning more about networking model. And before that, let me introduce you to the two types of networking model which are majorly being used there in the market. So the first one we have is OSI, which stands for Open System Interconnection. And the next we have is TCP/IP. And this stands for Transmission Control Protocol. And as we all know, IP stands for Internet Protocol. Now, before digging deeper into these networking models, I want you to understand the history behind the formation of these two models. So, when internet was not as common as it is today, and but when it was just being introduced to the world, there used to be no networking models. There were no TCP/IP, or we can say there was nothing like OSI. So at that time, vendors which used to, like big vendors like IBM, or you can say Dell, or let's say Apple, they used to have their own networking models for making the communication between devices possible. So what exactly used to happen was IBM had its own networking model and Dell had its own. Similarly, Apple had one, and let's say now the other vendors which were there who used to like manufacture the PCs, they had their own networking model for their devices. Now, when a network was there which was built only with the devices of IBM, let's say these three PCs all are, and their vendor is IBM, they all are manufactured by IBM. So in this network, the IBM proprietary of networking model would work fine. But let's say now there are two another PCs which are not manufactured by IBM, but they are like, let's say from Dell, and they have their own networking model. Now, if you want to connect these three PCs with these two, it would be a really complex networking thing. So to avoid all this complexity, there was a need of an open standard networking model. And what does it mean to be an open standard networking model is, so a model which can be used with any type of vendor or any type of vendor manufactured product. Now, when we think about this, we can understand this by taking an example of something like this. So let's say this is a person who speaks French and he speaks English. So if they try to communicate with each other, if this person starts speaking French and if this person starts speaking English, would they be able to communicate with each other? Would they be able to make the other person understand what they are trying to say? No, right? They won't be able to express whatever they are trying to say to the person who is in front of them. So they need something in common. So let's say this person also understands English and he's already an English speaking person. And now if they communicate, they will be able to make the communication possible. They will be able to we can say make the person understand whatever they are trying to say. So this was the need. So you can consider English as the need of an open standard networking model. So something which this person and this person both understand. Similarly, something which IBM produced computers and Dell or Apple or any other vendor manufactured devices understand. This was the need of a open standard networking model. After this, the organization which took the task to create something which everyone understands was ISO, which stands for International Organization for you can try to rejoin the session if you are not able to see the screen. I have already shared my screen. So the ISO stands for International Organization for Standardization. Now all this we are talking about is happening back in, let's say, end of 70s. So somewhere in the beginning of 80s, or you can say in the end of 1970s. Okay, so ISO took the task for creating an open standard networking model which can be understood by any vendor manufactured device. And with this, there was another organization. There were some individuals from DoD, which stands for Department of Defense. Now, Department of Defense of US. Now, some individuals from Department of Defense, with the help of various researchers, with the help of various researchers, started working on making another networking model of their own for their own use. Now, this ISO ended up making OSI, which we just discussed about, open system interconnection, and this DoD individuals, with the help of various researchers from multiple universities, they ended up to something known as TCP/IP, which we are still using and which dominates the networking models. Now there was a battle between OSI and TCP/IP. Both were like good in their own work, and both were able to satisfy the requirements of making communication between different vendor products, but only TCP/IP was able to succeed and OSI failed. Now, why this happened? Both were correct, both were right. Both were good in their work, but because of slower standardization process, OSI failed. Now, because of this slower standardization process, OSI failed and vendors started using TCP/IP only. Until now, we all are connected over TCP/IP. Now, TCP/IP, again, I am repeating, TCP/IP stands for Transmission Control Protocol and is developed by Department of Defense. And OSI, which was developed by International Organization for Standardization, stands for open system interconnection. So is it clear till now? Great. Yes. Now OSI is just a reference model, and we will know why we still talk about OSI. Why do we still learn about OSI when it is no longer in use? Then what is the need of talking about OSI? We will talk about that also. So moving further. So my question is, why do we still study OSI when the protocol which is being used is on every possible device there is TCP/IP. So when this battle was being held between TCP/IP and OSI, it lasted for some years. When this OSI versus TCP/IP was going on. Okay. So when this OSI versus TCP/IP was going on, this lasted for some years, and during this period of time, vendors started using terminologies. Vendors started using from OSI model. And these terminology remain till today. So when we refer to OSI model, even if I today ask you how many layers are there in the networking model, most of us will answer 7, which is there in the OSI model. So it lasted, it remains till today. That is the reason we are still referring to OSI model. And when it comes to the practical usage, the networking model which is being used is TCP/IP. Now we will understand how TCP/IP became the one networking model out of OSI and TCP/IP, which started getting installed in the vendor produced devices. So back in, let's say, in 80s, IBM had its own networking model, as I just told you about. Then there were other vendors with their own networking model, and they were connected like this, which was a really complex task. This was really complex to connect devices of one vendor with another vendor. Then when after the formation of TCP/IP and OSI, let's say IBM and Dell or other vendors, they started including TCP/IP and OSI both. Okay, so they started including TCP/IP and OSI both in their devices, so that the communication, the inter-vendor communication, can be successful. Right, Shubham, you are correct. Then after this was happening back in, let's say, 90s. And by the end of 90s, or we can say by the beginning of 2000, there was only TCP/IP. And OSI failed in the field of networking models. Is it clear to you guys how it used to work and how TCP/IP was like vendors started using TCP/IP only? Great. Okay. Now we will dig deeper into the networking models. We will understand how just a single click on internet goes from one device to another, and all this traveling of data goes from multiple layers one by one. We'll learn more about this. Okay, so let me check chat and see if there is some question or not. So you guys can post your questions on the Telegram group, and if someone is not connected on Telegram, let me know. I will share the link. Okay, so the question we have is why we use TCP/IP when we have OSI. We first of all had OSI. There used to be both OSI and TCP/IP. However, if we talk about the formal standardization process, the OSI was slow in that, and before OSI could make place into the standardization. Before that, TCP/IP got we can say TCP/IP had its standardization done before OSI. So this was the reason why OSI is still not in use. Yes, we can say it got approval from IEEE, which is an organization of Electrical and Electronics Engineers, Institute of Electrical and Electronical Engineers. And in all this formal, or you can say the process to get validation, OSI failed. It didn't just fail, it was just slow. And because of this slowness, TCP/IP succeeded and is still dominating the networking model. So OSI is still there. Why we still study OSI is we still have some terminologies from OSI and we can use it as a reference model to understand the flow of data from one device to another more easily, or we can say it helps us to understand this more specifically. Are we good with this? Great. Now we will talk more about OSI. We will learn about the different layers which are there in OSI model. So, open system interconnection or OSI model. There are 7 different layers, starting from application layer, then we have presentation layer, then we have session layer, then after that we have transport layer, and okay, someone is asking oh, I'm sorry guys, yes I can do that. So someone has asked OSI layer fails standardization of what protocols or something else. Okay, let me first of all make this clear to you guys. So why OSI didn't win the battle between TCP/IP and OSI? The reason behind this is standardization of protocols or whatever there is included in the OSI. So a networking model is nothing but a stack of protocols which defines a lot of action which we perform, which actually defines every single action which we performs over the internet. So for every action you do over the internet, there is a particular protocol. So if we talk about browsing the web, we have HTTP for that. If we talk about sharing files, we have FTP. Then if we talk about sending or receiving mails, we have particular protocols for that also, like SMTP. So there are multiple protocols under these networking models. So yes, there was some particular process of standardization. There needs to be some validation before application of these models in the devices. And because of the slowness, or you can say because of the slow process of this standardization, OSI failed and people just begin using TCP/IP. And when they found TCP/IP good, and since TCP/IP was also satisfying the requirement, the TCP/IP became the networking model which every vendor started using, and with that it dominated. Is it clear now? Great. So now we are going to talk about the different layers which are there in OSI. Then after transport layer, we have network layer. And after this, we have data link layer. Then at last, we have physical layer. Whenever you go to internet and try sharing some files, the data goes from, let's say if we talk about sharing files from one PC to another PC, the data from your PC will go like this. From every layer, it will go down until the physical layer. Then it will travel over the cables. Then at the destination PC, it will go something like this. Now what this down arrow and up arrow is representing here is, this represents encapsulation. And this represents decapsulation. Now what encapsulation means is, it collects the data from every layer and goes down. This is also known as top down approach. So this is top down approach. And this is up down approach. I'm sorry, down up approach. And altogether you can call it as layered approach. So when you send some data, it goes from application layer to presentation layer to session layer, then it reaches till physical layer. After that, it travels over the cable. Then when it reaches the destination, it goes from physical layer to data link layer and so on till application layer. So this is something which happens whenever you do something over the internet. Even if you go to your browser and browse some pictures, let's say if you search for some pictures of maybe car or anything, whether you search about anything, so at that time also whole process is being, so this whole process goes inside your computer, and this whole goes at the end at the destination, which can be a server or can be a PC. So is it clear how encapsulation and decapsulation works with OSI or TCP/IP model? So we will talk more about TCP/IP after the completion of OSI. TCP/IP is nothing different, but it has some different layers. And okay, sure. So what's happening here is, whenever, let's say this is a PC1, so this is your PC. The PCA is something which belongs to you, and then we have a PCB, which is, let's say, your friend's PC. So when you try to share some files with your friend B, the file first of all will go over these layers, and with every layer it will encapsulate some data. What does it mean to encapsulate data? It will attach some data with it until it reaches the physical layer, which is the last layer. Now after this physical layer, the data will be traveling over the cable. Let's say this is cable, and when it reaches the PC of your friend, which is PCB, now this data will be decapsulated. Now from every layer it will go up until it reaches the application layer. Right? Makes sense? Now when we have the data on the application layer, we can see it, and the purpose of sharing data from PCA to PCB is completed now. Is it clear now? Great. So now let's understand what exactly happens at application layer, then what happens at the presentation layer, and similarly on the other layers. So we'll talk about this now. We will also understand what exactly is being encapsulated with every layer, like what data is being attached with our original data, or we can say what information is being attached with our data at every layer. We will talk about that also, don't worry. So this is just a basic introduction how things work. So the role of application layer, let's first understand what exactly application layer helps in. So it provides access to the network services, let's say for different applications. So what exactly it does is it helps the application to show the data. We can say it provides services to different applications. Provides services to applications. Applications like a web browser, or you can say any chat software. So it provides services to make the data. Okay. So it provides services and helps these applications to make data visible at the destination or at the display of your PC. So let's say you are having a chat with your friend from PC A to PC B. So the service which will be helping your chat software, let's say you are talking over WeChat. So the services which are being used by WeChat to display the data is something which is related to application layer. So some of the examples are HTTP. When you go over the browser and you ask the browser to open google.com, so the page which appears is something which is being supported by application layer. So application layer is something behind which makes that page visible to you. Then after that we have presentation layer. Now you receive or send data in multiple forms. It can be a text, it can be an audio, or it can be an image. So with what type of data, what format is to be used is something which is done at presentation layer. So basically it assigns the format in which data will be represented. So we can say it assigns format in which data will be represented. For example, we have PDF for files for the text document, and this means application layer is, yes, you are correct. Application layer is something which we interact with. And for, okay, let's just talk again about presentation layer. Presentation layer assign format in which data will be represented. So for example, you got some audio files. So with that, we know MP3 will work. If you got some images, with that JPEG or some other related formats will work. So all this is taken care by presentation layer, right? Then after that, we have session layer. Session layer is responsible for creating multiple sessions, or let's say maintaining multiple sessions while you browse the internet. So you all must have used a browser. No, HTML is a protocol. I'm sorry, is HTML? No, HTTP is a protocol. Okay, HTML is. Okay. Yes, HTML is a language, and we can, yes, it is also a file format. So this is something which a web page use, right? Now let's focus on the session layer and understand what is the main purpose of session layer. So it is responsible for creating and maintaining different sessions. So you all must have used a browser. And when you go on a browser, you open multiple tabs, right? Let's say the first tab is for Google. And the second tab is there for Facebook. Then we have a third tab for, let's say, YouTube. Now, let's say the destination IP of Google is 10.10.10. Then for FB, it is, so this is just an example. These are not the correct IPs. Then we have for YouTube, let's say 12.12. And the IP of PC is 192.168, my favorite one, 10.1. Then there are 3 sessions being created with the help of this browser. The first one is being created between 10.1 and Google, which is 10.10.10.10. Then after that, another session 10.2 with FB, 10.3 with YouTube. So this is something which session layer takes care of. And with this, there is something also known as timeout, session timeout. So you all must have used internet banking, and you all must be aware about that when you leave the website idle for a few minutes, and if you are logged in, you automatically gets logged out. So this is also something which a session layer takes care of. It creates timeout sessions for websites, and it also maintains different sessions whenever you browse the internet. So is it clear to you guys now? Great. So with this, we also have something called PDU. PDU stands for Protocol Data Unit, and you can say it's a type of extension which we use for data after some information is being attached with our original data. So let's understand this now before moving further. Okay, sessions are made between SLC. Right. So between source and destination, there are some sessions created, which is taken care of by session layer. So I hope this is clear to you all. Now we will move further and we'll talk about PDU. Now PDU stands for Protocol Data Unit. Now the PDU is same for all these 3 layers, and data is known as data only at application, presentation, and session layer. However, when it reaches the transport layer, now the PDU for transport layer is segment. Now data is attached with some additional information, and now data will be known as segment. Then after that, for network layer, the PDU is PDU protocol data. So timeout is when a single transmission like this. I'm sorry, Raghib, I don't understand your question. So timeout is something when you must have used internet banking. When you leave the website idle for a few minutes, you automatically gets logged out. So that is something a session timeout. Are you able to understand this now? Great. So at transport layer, data is known as segment. Then at the network layer, we call it as packet. And then at data link layer, we call it as frame. And that's it. So now when data reaches the transport layer, it is attached with some additional information which is related to which type of transportation is going to be happen. So transport layer is responsible for, we can say, end-to-end delivery of data. Let's say we have a router here, this is the source, and then we have a router number 2 here, which is the destination. Now to reach the destination, there are two types of transportation available. Let's see, this is this is my bad drawing of a truck, and we have another transportation company. This. So we have two types of transportation companies. The first one is TCP, Transmission Control Protocol, and the other one is UDP, User Datagram Protocol. So now we will talk more about TCP UDP. Before that, I want you guys to be clear about application, presentation, and session layer. You all know what are the roles of these three layers. And now we are going to talk more about transport layer. Is it clear till now? Yes? Yeah, good. So we will now discuss more about TCP and UDP before moving further. And so these are the two available transportation types at transport layer, and transport layer takes care of end-to-end delivery. And what is data known as at transport layer? Data is known as segment. Now we will understand what is the difference between TCP and UDP. Here we have the first transportation type, which is TCP, and we have UDP. This stands for Transmission Control Protocol. Then we have User Datagram Protocol. Now, TCP is a reliable source for transformation. This is non-reliable. It gives acknowledgement. There is no acknowledgement. So let's say we send our data using UDP. The thing which will happen now is this truck of UDP leaves the source and will reach the destination. And once he reaches the destination, he will just put the data here and will go and will find another project. However, if we send the data over TCP, the TCP truck will reach the destination, will deliver the data, and after delivering will come back and will acknowledge that I have successfully delivered the data. So this is why we call it as a reliable source, and UDP is known as a non-reliable source. Is it clear till now? Don't worry, guys, please don't put characteristics of TCP and UDP, as people who are new to this might get confused seeing the chat. We will discuss everything, don't worry. And after that, if you think I am missing on something, you can put that in chat later on, so that I mean, it helps everyone, right? We some of us are experienced, but some of us are new to this, so it might create some confusion to them. Now these protocols have some numbers. The protocol number for TCP is 6, and for UDP it is 17. We can call TCP as connection oriented, right? It is connection oriented. However, when we talk about UDP, it is connectionless. So it doesn't care about creating connections. Make sense? UDP is non-reliable because it doesn't care about any acknowledgement. You are not sure whether your data was delivered successfully or not. And after that, UDP is something used for, uh, we can say, things like streaming. And while you stream anything, you don't have to make sure whether your data is being delivered at the other end or not, right? You just stream from your end. And example of TCP. Yes, we will talk everything about it. Till now, is it clear till now? Great. Yes, UDP is way faster than TCP because first of all, there is no such acknowledgement thing. Then after that, it doesn't care if your data was delivered successfully or not. It will just move ahead and will go and find the other projects, right? So you can understand this taking example of transportation companies. Let's say there are two companies, and the first one confirms whether your packet was or whether your parcel was delivered to the destination or not. However, the other transportation company, the UDP one, he just takes the packet from you, and after that you cannot question them that you didn't deliver my data or something like that. Okay, thank you so much, Shubham, for naming this. UDP applications are something like voice call or video streaming. When you let's take the example of Netflix. Let's say you are watching an episode of your favorite series, and let's say it is getting streamed live. So imagine, let's say the video buffers for 2 minutes, and after 2 minutes, you all know that the section you miss is missed. Whenever you see a live stream, the section which you miss because of bad connection is not going to repeat, right? And imagine it being repeated. So now after 2 minutes, you will see what is actually happening, which is happening live. And with that, now you will also see what happened before 2 minutes, right? When your connection was bad. So that's not going to help you, right? When you watch the live streams, you need to use UDP. Am I making sense? Are you guys able to understand what I'm trying to convey? Yes. So that's something where UDP is needed. And if we talk about sharing files, that's something in which you can use the TCP. So there is no such thing whether UDP is better or whether TCP is better. If we talk about live streamings, in that case, I would say UDP is better, right? Because I personally won't like my video being overlaps with something which I missed because of bad connection. Let's say I was able to uh, watch the video till 1 minute 50 seconds. Then there was some bad connection. Some packets got dropped, and now I am at 2 minutes. I missed these 10 seconds because of some bad connection, and it went all in buffering. So now would you like that after this time period, after these 10 seconds, at this point of time, you see the, like, now before moving further, you are like being made to see these 10 seconds, and with that you are also seeing whatever is happening at this period of time, that is at 2 minutes. So from 2 to 2:10, you see both the 10 seconds which you missed and also the 10 which are being broadcasted live. So would you like something like that? No, right? So we can't say which protocol is better, whether TCP is better or whether UDP is better. So they have their own work. In case of sharing files, I would say TCP is better, and in case of streaming or making some calls, we can say that UDP is better. You can also take the example of this live call which we are on. Let's say I explain you whole presentation layer for the next 5 minutes, but because of bad connection, you missed that part. Now after 5 minutes, when I am explaining session layer, you are being made to see presentation layer. So would you like that? No, right? That would create a lot of trouble. So in that case, in cases like these, when we are over call, which is a Microsoft Teams calls, the protocol which would be there will be UDP. Okay, both protocols are used. Yes, you are correct. So you cannot personally choose whether you want to deliver the data over TCP or UDP, but yes, UDP is something which is faster than TCP. So I hope you guys are now clear between difference between TCP and UDP, and we can move further with this. Now transport layer is also responsible for segmentation and sequencing. Okay, now I want you all to please focus here and let's understand what are the other roles of transport. I'm so sorry. What are the other roles of transport layer? So transport layer is also responsible for segmentation and sequencing of data. So what does that exactly mean is, so let's say you have a data here, and this is, let's say you have a message. Hi, I am Chirag, and you send this data from PC A. Now this will be segmented into smaller parts, or you can say this can be distributed into smaller parts. So let's say the first part we have is hi, then we have comma as a segment, then we have I, then we have am, then the last part, the last segment we have is Chirag. Now transport layer will number this, or you can say will gives a sequence to the data, and these as individuals can be known as segments. Now imagine this reaching PCB in a sequence 4, 5, 1, 2, 3. So it will be am Chirag hi comma I. So to avoid this transport layer gives a sequence to these segments, and when it reaches the PCB and reaches the transport layer of PCB, the transport layer will sequence it in the correct order, which is 1, 2, 3, 4, 5, and will show to and will display the message as hi, I am Chirag, which is the correct way. So this is also something which is transport layer responsible for. So basically there are 3 rules of transport layer. The first one is choosing whether TCP or UDP has to be used, and after that we have segmentation as a role of transport, then we have sequencing. Okay, so yes, to remember this, to like remember the names of layers, you can use please do not throw sausage pizza away. So that's something which you can use to memorize the names of transport, to memorize the names of these layers. So please for physical, then do not, do for data link, then not for network, throw, T for throw, T for transport, then S for sausage and session, then pizza for presentation, away for application. So this is something you can use to keep this memorized. Now after this we have network layer. Okay, so at transport layer, data is known as segment, and a segment includes this data, and with this data it includes information related to TCP or UDP. So this whole is known as segment. Okay, then after that, when data reaches the network layer, which is responsible for finding the best path to make the transmission possible. Now here this segment is, you can say, attached with source IP address, and then after that we have destination IP address attached to this segment. Attached to this segment. Okay, so we know that this was segment, right? This part of data was being known as segment, and this data is being carried from application, presentation and session layer, right? Then after reaching network layer, it is being attached with source IP and destination IP, and this as a whole is known as packet. Is it clear to you guys? So a packet includes information related to IP addresses, and with that it includes all the information which was there in a segment. Do you guys understand? Yes, data with the TCP or UDP header is known as segment. Now what is header? These information which are being attached before the original data, these are known as headers, and if the information is being attached at the end of data, it will be known as trailer. So this is something you can use while referring to these. So you can simply call it as a TCP UDP header. So is it clear to you guys now? Okay. Carrying data from one place to another, yes. Does transport layer provide? Yes. So I missed the question. What service does transport layer provide? Transport layer provide 3 services. The first one is choosing whether UDP or TCP shall be used, right? And after that, it takes care of segmentation of data. So it divides the data into smaller parts. Then the third thing which a transport layer takes care of is it gives a sequence to the data, so that even if it reaches the destination in wrong order, it can be sequenced into the correct order and can be shown correctly at the destination. Then after that, once this packet is formed at the network layer with the source IP and destination IP, it reaches the data link layer. Now when we talk about data link layer, this layer defines how computer access the media. So this layer defines something related to cables. So it defines which type of cable shall be connected between 2 devices. So the header which is available, which is like attached here, is source MAC. So this is something related to MAC address now. Then we have destination MAC. Then after that we have packet. And the PDU, protocol data unit, for data link layer is frame, or you can say all together these 3 things are known as frame. Now here there is